So let's talk about advanced storage topics. We're going to cover 4 topics in this slide deck. I'm going to talk about iSCSI, thin provisioning, tiered storage, and finally features on demand. So features on demand and iSCSI might be a little bit of a review from the previous quarter, but the other 2 subjects I think are going to be kind of new to this quarter. So first, let's talk about iSCSI, and just to review, iSCSI basically is the protocol that allows SANs to work. Most SANs work on the iSCSI protocol, most modern SANs. Basically, it's a way for using the IP protocol to carry SCSI commands over IP. So you can basically mount storage over IP networks. It's generally recommended that you use a dedicated network to do that. We've discussed a lot of that stuff in the previous quarter. So again, it carries SCSI device commands over IP network. So the 2 main components in Windows Server 2012 and newer that you're going to use to implement iSCSI are the iSCSI target and iSCSI initiator. So iSCSI target is a role, and the iSCSI initiator is a feature that should be included by default in Windows 2012 as well as Windows 8 and 10, although I think you have to install it for Windows 7. So that would allow you to connect to an iSCSI target. So basically, an iSCSI target is you once you have a local drive. So what you do is you create a local drive in Windows, but you don't assign it. You don't actually format that drive. You just make it a local drive. And instead, you make it an iSCSI target. And what happens is other computers can mount that drive over the network. So you basically turn your Windows server into a into a storage server, into a SAN, essentially. Now, of course, there are dedicated storage servers that can do this, so you don't necessarily have to use Windows to do this, but it is one of the things that we can do with Microsoft Windows. And I'm sure there are certain times when it makes sense to do so. So block-level storage means that the storage is seen by the storage client as a local drive. It doesn't see it as file level. So when you do file sharing, like Windows file sharing or UNC Pass, all the things that we talked about under advanced file services, those are file level storage. This is block level storage, meaning that it's seen as a physical device. That's why we don't format it on the hosting computer that hosts the target. So the iSCSI target makes storage available to iSCSI initiators as an iSCSI virtual disk, also called an iSCSI logical unit number, or a LUN. And LUN is one of those terms that kind of harks back to the old days with SCSI. But in iSCSI, every iSCSI target will have a LUN, or a logical unit number. And this is the ID to the logical drive that the iSCSI initiator uses when accessing storage on the iSCSI target server. So there are 2 components. As I said before, you're going to have the iSCSI target and the iSCSI storage provider, target storage provider. The steps for configuring the iSCSI target: you're going to install the iSCSI target server role service and optionally the target storage provider, which is really what you would use on the client side. And then you would create your iSCSI virtual disk, and then you create an iSCSI target and assign 1 or more iSCSI virtual disks to the target. So to create a virtual disk, to create an iSCSI virtual disk, you're going to use the wizard, or what I like to call the iSCSI virtual disk Sherpa. You will need to provide the following. You'll have to provide the virtual disk location, the virtual disk name, the virtual disk size, and the iSCSI target, as well as the identify iSCSI initiators, and select the authentication method. So you do generally want to use authentication because this is all on the network, and you don't want someone being able to mount to your storage that isn't supposed to. So generally we use authentication with iSCSI. So an iSCSI initiator is the client side. It's, as I said before, it's native in Windows 8 and later, but you may have to install it with earlier versions of Windows. So in Windows 8, 8.1, you get to that from the administrative tools in the control panel. And in Windows Server 2012 and newer, you can access it in the tools menu in the server manager, where we access everything else to manage our server. So when you open it for the first time, the property dialogs box will open, and you're going to specify a target that you want to connect to. It doesn't automatically reconnect unless you configure it to do that. So if this is going to be a persistent storage device for a particular server that's a client, you're going to want to make sure that you have it set to automatically reconnect. That way the drive letter always shows up after a reboot. And by the way, this step here, when you're opening up the iSCSI initiator, all of this stuff that you see here is important even if you're not using Microsoft Windows to host the SAN. So if the SAN is hosted on some other platform, you're still going to need to take these steps because you're going to need to connect to the iSCSI server. And this has become, I probably mentioned this in the previous course, but this has become really important because of virtualization. So with virtualization, a lot of times our storage is on a SAN because it's over IP, and it makes it very convenient and easy to do that. So this is what the dialog looks like when you're connecting your iSCSI target. Now, one of the problems with using iSCSI is you have to have all of this information. That target that you see there can be a complex. Take a look at the name that shows up down there. Nobody wants to type all that stuff in there if you look in the middle of that dialog box. So the Internet Storage Name Service, or ISNS, is an IP-based protocol to communicate between ISNS clients and servers. Well, that's pretty obvious, right? What does this really do? This is for publishing the names of iSCSI devices so that you can connect to iSCSI devices without having to put all that information in. So basically, you can query an ISNS server, and it will list for you the available iSCSI targets, and then you can choose the one that you want to connect to. Of course, you still have to authenticate to it, but this makes it a lot easier to work with iSCSI targets. So on large networks, it gives you scalability, it gives you manageability, and monitoring capabilities. So you're going to, iSCSI initiators use ISNS to discover iSCSI targets, as I said before. And iSCSI targets use ISNS by registering with ISNS server so that their status is available to initiators. So when you build an iSCSI target, it can register itself with the ISNS server so that it knows that that target is available, and it can register the various volumes that it has available. The thing about scalability here is in some networks, you're going to have a lot of iSCSI targets because you'll have one, at least one, sometimes several for each virtual machine. In a decent sized data center, you could have hundreds, even thousands of iSCSI targets. So this is a good way to keep track of those and not to, so you don't have to, keep those, in some kind of log somewhere or something like that with those long, complicated names. So to implement ISNS in Windows 2012, you're going to install, it's a server feature. So you're going to use the Add Roles and Features Sherpa or PowerShell. After installed, you're going to configure it by opening ISNS Server from the Tools menu in the Server Manager. So you have to configure the iSCSI initiator to register with the ISNS server. So you're going to add an ISNS server in the Discovery tab of the ISNS Initiator Properties dialog box. That way the initiator knows where to go to query for available iSCSI targets. If you don't put that in there, it's not going to know who it can query. So it's not like DHCP that we talked about in the previous lecture with broadcasts. So this is what the dialog box looks like. This is where you set up the ISNS server. So you only have to set this up one time, and then you'll be able to go in here and connect to iSCSI targets as they show up. All right, and there's some PowerShell commands you can use for managing iSCSI. Just like everything else, there's a few PowerShell commandlets that you can use. Now let's talk about thin provisioning. So thin provisioning is basically dynamically expanding virtual disks so that they only use the amount of space that's currently in use. And basically what this does, it allows you to use more space than is actually available on the physical disk. So if you only have let's say you have a 1 terabyte drive and you want to give 10 systems access to that volume using iSCSI, for example, using thin provisioning, you can have it so that each server gets 500 gigs, which is far more than you have available. But that's okay because most servers are not going to use all that space. Maybe only one of them is going to use all that space. The other really don't need it. And that way you can just give everybody a bunch of space and then let it get used as efficiently as possible. No one ever uses the entire hard drive, right? Take a look at your own computer. I guarantee you that you're probably not using even half of the space that you have on your hard drive. Most people don't. So it's much more efficient to share that space and over-provision it. Kind of the same reason that airlines book more passengers than they have seats because a lot of people don't show up, right? Or doctors book more appointments than they have in a day because they expect people to not show up and they don't want to lose money. We could do the same thing with our storage. We can use thin provisioning to over-provision our available storage, but that's okay because it's probably not going to get used. And we can certainly manage it. We can also do automatic trim and unmap, which when you select that option, if somebody deletes a file, it will automatically unmap the inodes so that it can free up that space on the disk. So that way, you're only literally using exactly the space that you need. There's never more space, as you delete files. So if somebody creates a huge file in their volume and then deletes that huge file, it's no longer going to require that space for that particular user. Tiered storage allows you to combine the best of both worlds, of both solid state, the speed of solid state drives, and the low cost and capacity of hard disk drives. Hard disk drives have a ridiculous capacity now. You can buy 2 terabyte hard drives at the store now for like $80. Even SAS drives have come down considerably in price for that kind of storage. So now we can have a tremendous amount of storage, but the trade-off is it's not as fast as SSD, where SSDs are extremely fast, but they're a lot more expensive for all that storage space. So it's nice to be able to combine both. So basically what happens with tiered storage is you can use both solid-state drives and hard drives in a pool, and the basically when the data is being accessed more often can be on the solid-state disks, whereas the less frequently accessed data is located on the hard drive. So hard drives are more kind of nearline storage, and then your solid-state disks end up being the online storage. So this is where you're going to set up the tiered storage in Windows when you create a virtual disk. So you can tell it, you can set the different tiers. So you have the faster tier and the standard tier. These are the PowerShell commandlets that you can use to manage tiered storage. And finally, let's talk about features on demand. And we talked about this in the previous quarter. So features on demand basically allows you to remove unneeded installation files and free up disk space that they normally consume. So every time you go into Windows add remove roles and features, which you do in almost every single lab, there's a lot of stuff in there. So once you build a server and it has the roles and features that you're using, there's no reason for all of those files to still be there for all the roles and services that you don't need. So you can use features on demand to remove those files. So here, this is when you run the get-windows feature command. It's going to show you all of the features that are available and installed. And you can see here that only 3 of these in this list are installed. The rest are not installed. So it would make sense to remove all of this stuff that I'm not, that I'm never going to use. For example, if I were setting up a Windows server as a DNS server, and that's all it was doing, there's no reason to have all those other files and the Active Directory and all that other stuff. So I can remove all that. So once you build and baseline your server, you can go in and remove all of the files that you no longer need. All right, so the most common way to do this is to create a feature file store, which is a network share containing the files required to install roles, role services, and features in Windows 2012. This is if you need to install features after you remove everything. So to create a feature file store, you're going to create a network share and assign read permission for the everyone group, and then you'll be able to install things off of the network share. So that's features on demand. All right, so we talked about in this unit, I talked about branch cache, file classification, and auditing, as well as global access network file system. Right, so we talked about all of the file access, all the file services. And then after we were done talking about file services, then I talked about storage services like using a SAN and ISCSI, as well as tiered storage, feature on demand, and so forth. So that concludes this unit.